Alrighty, so now we're going to look at scale factor and volume. And in this case, you can kind of see we've got these two boxes, and now we're interested in how much we could fill it up. So you imagine we increase this dimension by a factor of k, and then we increase this dimension by a factor of k, and we also take the height and we increase it by a factor of k. What we've really done is we've expanded this in three different directions by three different lots of k. And so for a similar argument that we can have with the area becoming k squared, in this case we're really taking the volume and we're multiplying it by k 3 times, which can give us two different formulas that we can use. K to the 3 is equal to the image V over the original V for volume, but we can also think of it as that the image's volume is equal to the original volume times the scale factor k to the power of 3. And you can rearrange these two formulas yourself by just multiplying both sides by original. Now, this is super duper useful because it can mean that if I know that the original volume of this one is equal to 3 centimeters cubed, and I know that the new one has a volume equal to 81 centimeters cubed, well, I can work out the k value. K cubed is equal to the image volume over the original volume. So the image is 81 over 3, which gives us k cubed is equal to 27, but I didn't want that. Take the cubed root of both sides to get rid of that cube, and k is equal to 3, meaning that if I had a side length of, say, 1 centimeter over here, well, the matching side length over here would be times 3, our k value, which would give us 3 centimeters. And so you can kind of start to see how these sorts of things work. By tripling all three of the sides, we get that the volume has been tripled 3 times, k to the 3. Alrighty, but we can also work the other way. So in this case, what if I had two balls and the first one has a volume of 6 cubic centimeters and I want to enlarge it by a scale factor of 10? What's the volume of the new one going to be? Well, volume of the image, no, other way around, image volume, well, that's just equal to the original volume times by k to the 3. The original volume being 6 centimeters cubed times by the k factor, which is 10 to the 3, gives us 6,000 cubic centimeters. And so the volume of the new one would be 6,000 cubic centimeters. So we can kind of use these in different sort of ways to allow ourselves to convert between the volumes and to play with the volumes instead. Alrighty, I'll see you in the next one. Goodbye.